All right, in the last section we talked about pairs of lines and angles, parallel lines, parallel planes, two lines cut by a transversal, which gave us our corresponding angles, alternate interior, alternate exterior, and consecutive interior angles. Well, now we're going to look at those things when we're dealing with parallel lines. And so let's start with our corresponding angle theorem. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So, as we recall, corresponding angles are on the same side of the lines, same side of the transversal. So, angle 1 is going to be congruent to angle 5, because as we can plainly see, we have right here and right here, we got these little arrows which says line P and line Q are parallel. So 3 and 7 are going to be congruent. 2 and 6 is going to be congruent. And not to be outdone, angle 4 and angle 8 are also congruent. Corresponding angles in lines cut by a transversal, parallel lines cut by a transversal, are going to be congruent. That's what that tells us. The alternate interior angles theorem says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. We remember that alternate, they're on the interior of the two lines and they alternate sides of the transversal. So we have angle 4 is congruent to angle 5. And we got angle 3 is congruent to angle 6. The alternate interior angles are congruent. Well, if the alternate interior angles are congruent, then the alternate exterior angles must be congruent as well. And in fact, they are. They're outside the lines, opposite sides of the transversal. So angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. This is when we have a parallel line cut by a transversal. All right, now the consecutive interior angles theorem, if two parallel lines are cut by a transversal, then pairs of, you guessed it, consecutive interior angles are not congruent. They are supplementary. Supplementary. Well, let's think about this. If 1 and 8 are congruent because they're alternate exterior angles, and 3 and 6 are congruent because they're alternate interior angles, well, 8 and 6 and 3 and 1 are a linear pair. So what we're going to get based on our vertical angles, our alternate interior angles, our alternate exterior angles, that angle 3, the measure of angle 3 plus the measure of angle 5 is 180 degrees, and angle 4 plus the measure of angle 4 plus the measure of angle 6 equals 180 degrees as well. Now, all these things give us a lot of power and a lot of tools to find the measures of different angles that we might be dealing with. So the measures of 3 of the numbered angles are 120. Identify the angles. Well, we know that angle 1 is 120 degrees. In fact, we're going to find all the angles. So 1 and 8 are alternate exterior angles. So angle 8 equals 120 degrees. Angle 1 and angle 5 are consecutive angles. So angle 5 equals 120 degrees. And angle 5 and angle 4 are alternate interior angles. So angle 4 equals 120 degrees. Well, since we're here, we might as well find them all. Well, 4 and 7 are consecutive interior. They're supplementary. So 180 minus 120 means the measure, oh, these are measures. Measure of angle 7 equals 60 degrees. 2 and 5. So the measure of angle 2 equals 60 degrees. Well, 7 and 3 are consecutive interior angles. So the measure of angle 3 equals 60 degrees. And 3 and 6 are alternate exterior angles. So the measure of angle 6 is 60 degrees. Or we could have done our linear pair with 1 and 2, 7 and 8, 3 and 4, 5 and 6, and we would have gotten the same results. All are legal, so we could use whatever method is easiest for us. So let's identify the measure of all our missing angles. So we need measure of angle 1, measure of angle 2, we have the measure of angle 3, the measure of angle 4, measure of 5, measure of angle 6, measure of angle 7, and the measure of angle 8. So 1 and 3 are a linear pair, so they got to add up to 180. So the measure of 3 is 75, the measure of 1 has to be 105. 1 and 5 are corresponding angles, so they have to be the same. 1 and 8 are alternate interior angles, so they have to be the same. And then 5 and 4, 1 and 8 are alternate exterior angles. 5 and 4 are alternate interior angles, so they have to be the same. Well, here we have angle 3, which is alternate interior with angle 6, so that has to be 75 degrees. Angle 3 and angle 7 are corresponding angles, so they have to be the same. Angle 7 and angle 2 are alternate exterior angles, so they have to be the same. So we've named all of our angles by knowing just one of the angles. That's the power of having parallel lines cut by a transversal, and the power of being able to identify by the name what type of angle we're dealing with. So find the value of x. So here's x. Well, what do we know about this value here? Well, we know that because of these arrows, that A and B are, line A and line B are parallel. So we know we have our goalposts here, so we have consecutive interior angles, so they have to add up to 180 degrees. We know that right here we have consecutive angles, so that is x plus 5. We have consecutive angles over here. We have alternate interior angles. So angle 4 is 115 degrees. So 115 plus x plus 5 equals 180. So we combine like terms. We get the x by itself. The value of x is 60. And we can just take any legal combination and keep working. Let's find another one. Let's do the value of x here. So here, angle 1 and 7x plus 9 are alternate interior angles. So I could write this up here. These two here are a linear pair, so they're supplementary. We know we got parallel lines, so this is true. So once again, 7x plus 9 plus 136 was 180. So we're going to combine our like terms. Get the x by itself. That looks like an 8. We don't want that. So what's the value of x? The value of x is 5. Because we know our parallel lines, we know that our consecutive interior, our alternate interior, our alternate exterior are all congruent, and our consecutive interior are supplementary. We also know that everywhere we have a linear pair, they're supplementary. So it can make it really easy for us to put these things together. All right, let's find the value of x. Parallel lines cut by a transversal makes it super easy. So we can have 120 up here by consecutive angles. So 2x plus 120 equals 180. Well, that's super easy, barely an inconvenience. X equals 30. We don't need to plug it in. We're done. Once again, same exact process, using what we know and putting it together in a way that makes sense to us. Parallel lines cut by a transversal, so consecutive angles are congruent. Alternate interior, alternate exterior angles are also congruent to each other. And our consecutive interior angles, which is a reminder, are these middle guys in here, because we seem to like to forget those, are supplementary. Well, let's see how they go together. Well, this and this are alternate exterior angles on the outside of the lines, alternate sides of the transversals. So 6x minus 3 is going to equal 129. We don't have to use supplementary in this case because they're going to be equal to each other. So that's what I mean about having to know the rules so we can apply them. So let's get the x by itself. And then we're going to get x equals 22. We only had to find the value of x, so we're done. All right, so these next two, we're going to use this diagram over here to help us. We have parallel lines cut by a transversal. So, and these two are going to work independent of each other. So don't try to put them together and say that because of what we have in the first box has to also work in the second box, because they don't. All right, so the measure of angle 1 is 105 degrees. Find 4, find 5, and find 8, and tell which theorem you used in each. All right, so the measure of angle 4, I'm going to go right down the line, equals 105 degrees. Why? Because vertical angles. Like we learned in a previous video, vertical angles are congruent. So 1 and 4 have to be the same. The measure of angle 5 is going to equal 105 degrees. And I can use corresponding angles with angle 1 or alternate interior angles with angle 4. So the measure of angle 8 is going to equal 105. So I can do alternate exterior with angle 1. I can do vertical with angle 5. I can do corresponding with angle 4. All are legal, all work, all give me the solutions that I'm looking for. All right, so we're going to use the same diagram, but we're going to put different information into the diagram. So given that the measure of angle 3 is 68 degrees, so we've got a 68 right here, and the measure of angle 8 is 2x plus 4, what is the value of x? Well, that's 68, this is 68. If 8 is 2x plus 4, 5 is 2x plus 4, which makes them supplementary angles. So 68 plus 2x plus 4 equals 180 because our consecutive interior angles right here, they look like goalposts, are supplementary. So now all I gotta do is combine my like terms. Get the x by itself. Divide both sides by 2, and x is going to equal 54 degrees. Done and done. All right. Now we're going to prove that two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So we want parallel lines cut by a transversal, and we want to prove that angle 1 and angle 2 are congruent. So we're given that line P is parallel to line Q. Awesome. We have a transversal there. So we know that angle 1 is congruent to angle 3 via our corresponding angles theorem. So 1 and 3 are the same. Check and check. Well, we know angle 3 is congruent to angle 2 because of vertical angles. And angle 1 is congruent to angle 2. Our handy dandy, much beloved transitive property of congruence. So proof that the alternate exterior angles are indeed congruent. All right, so here we got a story problem, or as I like to call it, a real life problem. So sunlight's going to enter a drop of rain, different colors of light leave the drop at different angles. That's how we make a rainbow. For violet light, the measure of angle 2 is 40 degrees. What is the measure of angle 1? Because there's a sun up here, and that's where these rays are coming from. We have our little arrows, so we know these lines are parallel. So what is the measure of angle 1? Well, it's 40 degrees. How do we know that? Well, the sun's rays are parallel, and angle 1 and angle 2 are alternate interior angles, because we learned that in the last section. And by the alternate interior theorem, which we talked about at the beginning of this section, alternate interior angles theorem, I skipped a word. Angle 1 is congruent to angle 2. That's how we know. So we are